exterior angles of polygons. Quiet and listen, please. Today we're going to go over different properties of a parallelogram. Okay, so a parallelogram is a quadrilateral with two pairs of opposite sides that are parallel. So you can see that in this figure below here. Okay, I have one pair of opposite sides parallel, and then my second pair of opposite sides parallel. Where again, these arrows within your side means that it is parallel. Okay, so I have a chart here for your properties of a parallelogram. So the opposite sides of a parallelogram are congruent to each other. Okay, the opposite sides of a parallelogram are congruent. So if I look at my figure above here, one pair of opposite sides would be PS and QR. So PS is congruent to QR. Okay, the other pair of opposite sides here are PQ and SR. So those two sides are also congruent. What? Okay. Next, we have opposite angles. So within your parallelogram, opposite angles are also congruent to each other. Those are the angles that are across from each other. Okay, they're opposite to each other. So in this picture here, we would have angle P is congruent to angle R. And we have angle S is congruent to angle Q. Okay, so we can see these angles are opposite and they're congruent to each other. Okay, next we have consecutive angles. Consecutive angles are supplementary. What does supplementary mean? 180. 180. Okay, so they add up to 180. So consecutive means that these angles are next to each other. Okay, so the angles next to, so like angle P and angle S, those ones are next to each other. So if I take the measure of angle P plus the measure of angle S, they should add to be 180. Okay, same thing with angle S and angle R. Okay, those two angles are next to each other, so you can add them to be 180. And QR and PQ. Okay? In your parallelogram, if you have one right angle, then all angles are right angles or equal to 90. Okay, so if you're given that it is a parallelogram and one of your angles is a 90-degree angle or a right angle, then all the rest of them also have to be right angles. Okay, our next property has to do with diagonals. So the diagonals of a parallelogram bisect each other. What does bisect mean? Cuts it in half. Okay, so up here, if I were to draw in these diagonals, okay, those two diagonals intersect at a point in the center here. Okay, I'll call it point M. Okay, so this diagonal SQ will bisect this diagonal PR. So that means PM is congruent to MR. Okay, so it bisects that diagonal. Same thing for SQ. So this diagonal PR will bisect this diagonal SQ into two equal parts. Okay, so then I would have SM is congruent to MQ. Okay, our last one here Your diagonals separate the parallelogram into two congruent triangles. Okay, it'll separate that parallelogram into two congruent triangles. So if I look at this diagonal SQ, I would have this triangle up here, SPQ. Okay, so triangle SPQ would be congruent to, and then looking at the second triangle created with that diagonal, that's this one right here. Okay, that would be congruent to triangle QRS. Okay, so it splits it into those two congruent triangles. You could say the same thing about the diagonal PR. So you'd have triangle PQR and then congruent to triangle RSP as well. Okay, questions on your properties? Okay, so we are going to apply these properties to solve for different sides and angles within parallelograms. So we're going to do the first one together here. Okay, we want to solve for our variables A and B. If this figure at the right here is a parallelogram, so A, B, C, D is a parallelogram. Okay, using these properties, I want to solve for A. So one of my properties for parallelograms has to do with opposite sides. Up at the top, what does it say about opposite sides of a parallelogram? They're equal or congruent. Okay, so to solve for A, I can set those two sides equal. Okay, so we would have 2A is equal to 34. Okay, to get A by itself, we divide both sides by 2. 17, yep. Okay, so A will be 17. Now we still have to find B. Okay, so I see I have angle A here for B, and there's an angle across from that, so angle C. Okay, those are considered opposite angles. What do our properties tell us about opposite angles, Andrea? They're the same. Okay, so since these are the same, I can again set those to equal to each other. Okay, and divide both sides by 8. To get 14. Okay, questions on our first example? All right, I want you to try the next 4. Okay, look at your properties above. Okay, try and connect those to those examples.
Garrett. Yeah.
Otherwise, you have the option of taking training college math 1, or you have the option of taking algebra 2. Technically, up to you. By this point, you should have 3 math credits if you pass that this year.
All I heard is like you want to be harvest or something like that.
Something like that. Every bath.
I got like
So I'm getting a haircut.
No.
I think I did the first one. And I got it from mine. Yeah, technically 2 points.
Like, do you know how like yeah, you grab it like tight. So you can still
Isn't it just 6x divided by 12 on number 3? Because all of them are the same. 12, well.
Didn't do it.
Yeah, that's why I did.
That's number.
Yeah, I know.
What do you use? 5x.
So what if you do 5x and 6x? Like,
Oh my god, oh my god, oh my god.
oh my god. Triangle stuff is so this one's SP equals
Yeah.
Well, they're all why can't we do it? Like I know we get it here, but that's all of them.
Well, that's this.
We're not doing the same
First
thing.
one,
We had there's no other way.
So then I would be like,
for all I care, someone be writing yeah, I don't they have a lot of that's what it is. I don't freaking buy it. I don't they have a lot of animals. For each design, there's a whole bunch of colors. Each little design. Every show. I got one of us. If he brings it.
And so if this equals 12, what does that equal? Yeah, so make that equal 12. Some people say so 3x equals 90, that's
I didn't do one. For real?
How do I get this?
What do you know about these angles? Well, these are called consecutive angles, 6x and 12. They're
So is that 6
I think he plugged
So 120 divided by 3.
where you get one.
All by 6.
Sorry, I gotta get
What the?
I'd say it's time for break.
I know that, this thing crazy.
Oh, really? Hey, Hannah, there's grass out there. It's easy.
This plus that.
So the south.
Okay, one question real quick. Okay, do we go up or sideways first? Yeah.
Any volunteers to show me how to do this problem up here? Go ahead, Ashley.
Wait, do I have to talk? Should I just draw it?
Just say what you're doing as you're writing it.
Okay.
How about number 2?
I will.
Pear. Just what properties do you have?
Let's go, alright.
Consecutive angle. Wait, can I do the top one?
Here.
The golf ball. The golf ball. Can I do one?
I just got it.
Yeah.
Give it a
Whatever happened to that t-shirt?
What?
That one with the clouds. Folks.
I know with the cloud, dude. You just want to tie that?
So you're oh.
Eric, this is the
Wait, we're on the
Jeremy.
Oh, dude, oh, this is gotta do 180 miles.
Calling him back up from the whoa, this is really neat. Holy.
Hey, dude, don't you dare.
Whoa, shit.
You have a minute for me. Losing.
We're doing this.
Don't you dare. I said it. I don't like it. And they just crumble the ball. The minute and 30 seconds.
Oh my gosh.
Do I have one more volunteer for 3?
This is really confusing.
Do we get extra credit?
No, you're wrong.
So I'll give you a high 5.
Sweet.
That's not worth
I wouldn't
it.
do it for free, but I'll take a high five.
There's always.
It's hard for you to someone else.
Hey, guys, fire today?
Oh yeah!
Nick, I'm coming with.
Oh my goodness. It's messing with my brains.
Hey, I'm gonna fire today.
Okay, there's that one. And now one. This marker is like.
This one's dying too. I mean, it's not bad. But like,
That's really.
We're coming over.
Good. Hey. Okay, no. This marker is not very good.
Oh, man.
72 points.
Hey,
Sure.
swear.
It will really exactly. Jeremy.
Alright, I need you to come back together here. So quiet down for me. I don't need Emily to explain this, I want somebody else to.
Well, I'm saying it's
Somebody else explain it. Go ahead, Brian.
So, since one angle is 90, they're all 90 according to the, if one right angle, then they won't. So you set up 3x equals 90, divided by 3 to get x equals 30, and do 4y equals 90, divide that by 4 to get 22.5.
Good job.
This man is a genius.
Alright, somebody explain number 2 to me.
Well.
Go ahead, Emily.
Okay, so you add 60 and 55 together to get 115. So then you do 5x plus 115 equals 180. Then you subtract 115 from both sides. And then you get 5x equals 65, and then divide that by 5. And you get x equals 13.
What type of angles are those?
Yes, consecutive.
They're consecutive, good.
And then for the y, you do 115 plus 2y equals 180. And then you get 2y plus 2y equals 65, and then divide both those by 2. You get y 32.5.
Yes. Because these are again what?
Consecutive.
They're consecutive. Okay, so consecutive, you have those angles are next to each other, they add to 180. So you do need that entire angle there, not just 60 and not just 55. Okay, that entire angle within that parallelogram. Okay, explain number 3 to me. Someone? Anybody?
Sarah?
Well, the lines mean that it's equal, and you take 6x equals 12, and you divide that by 6, and you get x equals 2. And you do the same thing, 3y equals 12, divide that by 3y equals 4.
Right, because what do we know about these sides? Are they? They're congruent. Alright, number 4. This one was a little bit more challenging. Go ahead, Hannah.
So you just equal because they are they're supplementary angles because the two x's. So you just add the two x's and equal to 180, and then you get 18. 80 you just divide by 18 from 180, you get 10. So then next you have to plug it in with one of the x's. So I just used 6, and I got 60. So then you just add 60 and 3y equal 180 because it's still supplementary, and then you cross them over and everything, and you do 120 divided by 3, and you get 40.
Thank you.
Good job.
Does anybody have questions for your classmates about that work?
Can we get some money?
Some money. Nobody has any questions here?
No,
You understand these problems a little bit better now?
Yes. Don't erase number 4 yet.
Or 2.
Alright, so I want you to go to the back of your note sheet. Okay, I want you to do the 2 problems at the top, just like you did the ones at the bottom on the front. Okay, 2 problems at the top. Once you finish those, you can graph your points in the graphs below. Okay, graph those points, and then I'll tell you what we're doing with those after we're done with those other 2 problems.
Am I supposed to connect it out?
Yes. Okay, so work on those 2 problems at the top using those same properties. You good?
No.
Are you good? No?
I'm writing number 2.
He just
Like
needs 2.
2?
Yeah, you can erase 4.
Okay.
Boy, you can figure it out too.
Dude, shut up.
I had these 2 up. Okay, they are connected. I see it.
I got that. Hold on. I think this is one. Yeah, I think you pulled your thing down too far. I put this one. I did that thing. You're wrong, brother. That's perfect. No, that whole wants water. Hey.
Leroy Nike SB shirt.
Leroy Field and Nike SB shirt.
That was nice on my skin.
Yes, sir.
Wow.
It's a very nice color.
Fucking stuff. What is built on
I know you.
Make sure you do those two problems at the
Just
top.
wait, you put your in for this.
That's a fact. Isn't that a fact?
Take the old lady should have done it earlier.
Right? Is that a fact?
Can't fit 10 people in one hole.
What's going on?
Why don't you beat up with your own?
Why?
Why not?
You can drive it.
It sounds like a good idea. Oh, I got the sled in the back of the
Wouldn't it be
head.
like 3x?
It's still in good condition.
Hey, guys left like half that sled out there. You left your war balls.
Isn't it
You ever
3x?
find my, you ever find my, hey, Preston, you ever find my Burton mitten?
That's in my van.
I
Is it? Yeah, one of them is.
Oh, the other one was on the back of the four-wheeler and it wasn't there. Sometimes. I'll have to go out here with the good old metal detector. Around a little bit. You know where I can blow my snot?
Oh, there's
I love grabbing.
Yo, those are sick boots.
So those yours? See, I don't know if
You're not gonna have any.
or draw away.
Are these yours?
Yeah, those
I
are
drew
mine.
all the way through first, and then I wanted to make sure.
They're right next to your bubbles.
They're not my bubbles.
You store your bubbles next to your shit.
They're Alexia's from back. All right, I want you to come back together here. I want somebody to raise their hand and tell me how to solve number 5. How should I set up an equation? Go ahead, Summer.
do 3x is equal to 12
Why?
because
Which property on the front?
opposite.
The opposite angles.
What?
Help her out with the property that she's using.
She's using
17.
diagonal.
Yeah.
What about the diagonals?
It's 5, 6, 6.
It bisects it. Good job. Okay, so that's what we're using here. All right, Summer, what should I do next?
Divided by 3 to get.
Okay, what about y? Somebody else help me.
So you just do pretty much the same thing because it's pretty much the same thing.
So what should I write?
So 4y equals 8, and then do the exact same thing. So divide by 4. You decide y equals 2. Merry Christmas.
Thank you, Hannah. All right, what about number 6? Somebody help me out. Somebody other than Hannah. She's participated a lot today. Number 6, help me out.
Set 2y, 28, so to make it like number. And then divide by 2.
Yeah.
And with 4, since the lines are both congruent, so set 4 equal to 28 as well. Divide by 2.
Did you all hear what he said? Because there's a lot of conversations going on. Say it again, just for good measure, Adrian.
Like all of it?
No, just this part.
Oh, alright. Since lines are both congruent, take 4, set it equal to x. Set 4 and set it equal to 28, divide it.
Thank you.
Thank you.
Okay, questions on number 5 and number 6. All right, you should have plotted these points for 7 and 8. Shh, quiet. Plotted these points for 7 and 8. So number 7, point A is at 3, 6. Okay, B is at 5, 8. C is at 3, negative 2. And D is at 1, negative 4. Okay, so this is creating a parallelogram. Okay, it is a parallelogram. So what the directions want us to do is find the coordinates of the intersection of the diagonals. Well, we know diagonals meet at a midpoint because diagonals bisect each other. So what I can do here is take 2 points that are across from each other, like point A and point C, and we want to find their midpoint. Okay? The midpoint formula is x sub 1 plus x sub 2 divided by 2, y sub 1 plus y sub 2 divided by 2. So we can take those 2 coordinates that are opposite each other and find that midpoint to find where our diagonals will intersect on a graph. Yes. So up here, I would have x1, y1, and x sub 2, y sub 2, and I can just plug that into that midpoint formula then. Okay, so x sub 1 is 3, x sub 2 is 3. That's divided by 2. Y sub 1 is 6. Plus y sub 2 is negative 2. Divide that by 2. So we have 3 plus 3 is 6 over 2. 6 minus 2 is 4 divided by 2. So our point will meet at 3, 2. And if you were to draw in that other diagonal, you could see that. Okay? You could see those diagonals intersecting around that area. Okay? So that would be your midpoint. So, I do want you to do that second one there. So if you haven't found the midpoint for number 8, okay, I want you to find that midpoint. Where will those 2 diagonals intersect in the graph that you drew in?
I will do that tonight.
Okay, no, you're going to do it right now. Right now.
My brain's just optimism.
No, right now.
Wait, can you after this for me?
I already did.
It is. You actually have to find that midpoint.
Oh yeah, I
I
saw
like
that.
the graphic. Did I tell you that?
It's a picture. This computer better work. Well, I thought they were tuning some of it does.
Oh, wait,
He gets it all. You want to like make sure. No, you don't do it. Bring the sack upstairs.
I said take that. Yeah, I do. I do that.
It was like a minute and 38 off, so there was timeout.
Garrett.
I'll be
Alright, finish up that last problem, and then on Monday we'll work on extra practice problems with this.
Am I